Now, this is both a contract issue, a programming issue, an architectural issue, an engineering issue. There's a lot of things that go into how this can be used against a smart contract in our environment, or even just the person's wallet or the contract wallet. So this is one of those things that you really want to be aware of as a programmer and try to take as many steps to solve this problem as possible. Now, at some point, if you're running a modern distributed application, if you're running something that needs data off the chain, right, this is where you're going to use an oracle. And these are basically data sources or places that are off chain where you can go ahead and pull information stored and use it. Right, and it's kind of necessary. Decentralized applications can become really more valuable by using off-chain data inputs. It also can sometimes make your contract work a lot quicker, can smooth out a lot of issues and other things. Now, you're running a prediction market, you're doing something else, you really are going to employ oracles to provide up-to-date information about outcomes that can be used for, like, what's the price of Ether, what's the price of Bitcoin, what's the price of this stable coin, what's the balance on this liquidity pool. All that stuff's going to happen, and you're going to need it, and you're going to want it. Now, there are several types of oracle based on data source, so like one or more sources, the trust model, whether it's centralized or decentralized, and the architecture of that oracle. If you're building an oracle, there's a lot of decisions that go into this, because you're going to be doing, whether you're going to do a publish subscription, request response, immediate read. How are you going to build around this? And if you're building a contract, these are some pretty valid questions to be asking, especially if you're looking at spending money on someone that's doing a subscription model. How are they built? How are they set? And what protections do they have in place? Now, the type of oracle could be distinguished by whether it retrieves external data for on-chain contracts, sends information to off-chain applications, or performs computational tasks off-chain. And again, your goal here with your contract is to try to make it run as efficiently as possible. And sometimes taking some of your computational tasks off-chain makes an awful lot of sense. So oracles have a problem, right? And that is, can we verify that the injected information into the contract was taken from a correct source or data that hasn't been altered? How do we validate that data? How do we make sure that the data is available and updated regularly and accurate? And that accuracy is going to matter, especially if you're doing conversion between two different cryptocurrencies, if you're paying someone from one cryptocurrency to a different cryptocurrency, if you're a liquidity pool, a bridge, anything. That ability to be accurate is going to really define how well your contract operates, right? And that problem is just going to demonstrate the challenges involved in setting inputs to smart contracts using blockchain oracles. Again, remember, it's kind of isolated silo stuff, and now you've got some crucial data from an oracle that has to be accurate. Otherwise, your smart contract is going to produce an incorrect result, and you don't want that. You really don't want that. So you have to be trustlessness as another important factor, right? Smart contracts would lose their most defining characteristics if they had to rely on oracle operators for accurate information. So you really want to make sure that you're getting the information, but you can trust it, but you don't necessarily have to trust it if you don't need to. It's a weird zero trust kind of balance that you have to strike here. You still have to be able to function, but you still have to be able to validate the data, or at least validate where the data came from. And that can be different to solve. So you have some different solutions to the problem. One of those is correctness. So smart contracts should not be triggered by off-chain data that is invalid. And again, there are techniques around here to make sure that the integrity of the data, the authenticity of the data, means the data was gathered from a reliable source and that it remained intact before being sent on-chain. Right? So you have a way of validating and authenticating the information. That the data is available, right? So you get into the CIA triad here really much on a lot of ways, right? Smart contracts should be able to execute actions and trigger state changes without being delayed or prevented by an oracle. Again, you get into these delays in the oracle, you may end up with problems, something may get hung, you lose flow control with that problem. So the oracle must be able to supply data on demand without interruption. So that means the oracle has to be robust enough that if a chunk of the oracle is down or there's a network issue or something else, there's a global way of getting that data into your smart contract. And then incentives, right? A smart contract oracle should incentivize off-chain data providers to submit correct information. There's nothing worse than going out to the NASDAQ and going in. And I don't know if you've ever bought stock before in the past, but you put your order in the morning before the market opens up. And if they don't transact right away, you may end up paying more for that stock. I remember when I was buying stocks and thinking, oh, wow, I'm going to make some money doing this. I would do that in the morning because I'd see that pre-open market price thinking that's what I was going to get. And by the time they got to my stock buy, all the big institutional investors had already gone through. The stock price had either gone up or had gone down. So I didn't get what I thought I was going to get. I didn't get the price I was going to get. So there was no accountability on that, right? And there was no incentive for that provider that I was using at the time to buy and sell stocks to really just give me the best price they could. Give me an honest price because of the way the data worked, right? So data providers were not being held accountable for the information they provided. And that's a real big problem. And you can solve some of that by doing your Oracle and your smart contract different, making sure that they're rewarded or penalized according to the quality and the timeliness of the data that they provide. And that brings us to Oracle design. Now, services based on the publish subscribe mechanism will basically give you an API. It's basically a data feed. You would pull from that data feed whatever information that data feed was supposed to give you. Now, what makes this interesting in a lot of ways, because it is going to be hit by a lot of different contracts. So whoever is providing that data feed, you want to make sure that there's frequent change of data and that the client contracts must listen for updates in the Oracle storage if they're doing that model, right? For example, an Oracle provides users with the latest Ether to USD price. A great example of that, right? Because you're going to want to pull that down, but you have to make sure that whatever's in storage or from the API, the output is actually what's reflective in the Ether USD price today. And we know, or at that minute, or at that second. And we know that Ethernet prices can vary widely, right? I've seen some of these things, I subscribe to Coinbase, and I see some of these wild variations. You see that dropped 5% one day and went up 10% the next day. I mean, it's like watching wild mood swings happen. So you want to make sure when you're pulling down that Oracle price, you are getting a near to exact moment because of the way these markets can really swing a lot. So for stuff like your pull, your publish subscribe, make sure your data is like really reflective of the market at the time, especially if you're doing value transactions. Now, the other thing that was interesting too is the request response design. With a request response setup, it's an alternative to publish and then subscribe, right? The request response Oracle is like the publish subscribe model, and that it's more complex. In the Oracle, the data request will be received on chain and passed off chain to a processing node and then sent back. So there's another step in there, right? You're still tied to that blockchain feel to the whole thing, right? So a user initiating a data query covers the costs associated with retrieving information from an off-chain source. The callback function, again, the request must also be funded by the contract client to cover the gas costs associated with returning the response. So that's a little bit more expensive. As long as the data is good, you don't need to stay in that idea of having to pay for the transaction costs. A lot of the problems that you have with some of these attacks, especially things like front running, is that we're manipulating the gas price to get something. And if I can do it through doing an Oracle and I can get that transaction block set up so that I'm hitting gas limit for that block, then I can do a lot of really crazy things with the process. So with an Oracle, I want to make sure I'm probably not going to want to go with a way that increases gas price because I don't want to register those kinds of transactions. No need to, right? So types of Oracles, they're generally going to be a subscription model for data, right? Again, just really straightforward. A centralized, generally going to be your subscription model. Not that a decentralized can't have a subscription model as well. The reputation lies in the reputable data access and speed, and that there's kind of a data guaranteed for correctness if used at that point in time when it's being called. Now you might have some geographic restrictions or availability that leads to poor availability of data in some geographic locations. The one thing I've noticed too is that some of these systems are behind big systems like Tor, the Onion network, and that can cause problems along the way. So if you have a centralized Oracle, then there's network issues or logistical issues in terms of whether your physical locality, geographic restrictions are, you can get some really interesting data problems to happen. Now the other one is centralized, decentralized. And even with the private data providers, or like others, um, you really don't get a single point of failure wherever your contract resides. You have the data points and you can pull them down. The companies that are selling these on the publish subscription model really have gone to a decentralized viewpoint. So while it may not have a centralized administration, decentralized or semi-decentralized, there is open participation of owner-approved connections, right? So you have to do the process for this to get approved to attach to the API and use the data. Now, there are multiple approaches leading to authenticity and integrity guarantees of the data. The other thing I kind of like about this, multiple different kinds of technology to make this work, right? Transport layer security, HTTPS, you're going to be using your API and using SSH. You can use a trusted execution environment. You can do a consensus-based data provider. There's lots of really good incentives and lots of good ways of providing good, accurate data and making sure that data is not manipulated in transit. So there's a lot of different approaches to how decentralized works. It just depends. The first decision you're going to make as the contract writer is, do I want to go with centralized or decentralized? And then from there, working out who do you want to work with. But you just need to know what kind of processes are available to you. So like this one is kind of one of those just example chunks of code, right? That, we're going to go and do an aggregator for ETH to USA. We've got a wallet address. We just want to check and see what the price feed is for that V3 interface. And then we want to return the latest price. And we're going to return it as an 80-bit UINT with a rounding ID, a price, started out at a timestamp, and then answered in round, right? So then your price feed is going to be the latest round data, and then you return that price to the constructor. And that works. That just makes it work so you get the latest price on the whole process. Now, there's a lot of issues with this code. All right, there's no validation, there's no multiple things. We are looking at a timestamp, but we don't set a variation schedule on this. We don't use a time aggregation on this to get a range of times that this would be an approvable or permissible amount of time, right? And because we don't do that, we can get some really good spot price manipulation, right? That single feed source allows someone to manipulate spot prices for flash loans. And this is really kind of clever because, I love the people that comes up with these things because they really do kind of open up that door on thinking, right? You're going to increase the price for asset A while reducing the price for asset B. And basically you're pumping this by doing the flash loan to actually say, I'm going to buy a bunch of asset A at this price and sell asset B at this other price at a lower price. And it works out in such a way that you walk away with more money than you would have, right? So you don't ever really want to use spot pricing in terms of your code or time calculation. You really do want kind of more of a secure price calculation by using what they call time-weighted averages across longer time intervals. And that will really make the cost of price manipulation way outside the realm of doing it, right? If it's more expensive to do it, then it's really worth, they're not going to do it. And that time-weighted average can really help out, especially if there's some wild mood swings going on in the market and Bitcoin or Ethereum are moving up and down in rapid succession throughout the day, right? And again, that's your downside because even a 1% variation across that time-weighted average can mean a really good reward at the current price. So like, you have a price for Ethereum of 1,500, 10% is 150, 1% is 15. And depending on how many I'm doing here, I can make some money. And that's all that really they're interested in. And that's why flash loans can be a really interesting way of making money because of those variations. If you can pin it so you get a better variation, you can make even more money. So the other one that's interesting too is that idea of off-chain data. Because off-chain is going to rely on traditional software. And we've mentioned OWASP a number of times. There's a whole couple of lectures on what OWASP is all about. So you do have some risks and exposures that traditional software is going to provide and give you. So you do want to make sure you're taking care of that, right? You always want to have more than one source, and that's just a given. And again, that time value weighted average, but be aware of daily, if not minute by minute fluctuation. So again, back to the flash loan, it's the same kind of process, right? The programmer is going to want to make sure they're using good data sources, good data feeds, aggregation of data, time value weighted averages, and the ability to interrogate and dispute data that's hugely out of variance. And you can set what that huge variance is. Now, again, I've seen Bitcoin alter by 5% per day. There's one day where it dropped like 12%. So if I set my variance for plus or minus 5%, then that 12% would be a huge variance. And I could be able to dispute that data and see if it really was provably true. And then if provably true, then use it. So you want to make sure your contract does this. And there's a couple of really simple attacks on this: freeloading and mirroring. Right? Freeloading, basically, I'm going to use an untrusted public API. I don't want to pay for any kind of subscription costs. I just want some data. I'm not going to worry about who's providing it. I just want to freeload off somebody, and the data can be coming in off that API, can be manipulated, it can be incorrect, and it can provide a really valuable opportunity to a person that wants to clean out your liquidity pool. The other one I thought was interesting too was mirroring, because you're basically the same kind of idea, getting data from a data source, but that data source has a low sampling rate. So if you're checking the price for Ether, if it's sampling every hour, that will probably give you a different price than if you're sampling every minute, right? And that's the idea here with mirroring, is that the node is replicating that low sample rate data to other nodes or other contracts, meaning that there's faulty data across the system, especially if you don't update it or you have to update on a timer. Instead of pull down data right away on need, you're storing that information somehow and then using that stored information to try to save gas. So freeloading and mirroring, again, just low quality data from untrusted public API or low sample rates. So you want to ask that question when you pick your provider. What's your sample rate? How fast do you sample data? So that's essentially on this one, the solutions, right, for this. Just use a decentralized Oracle. There's lots of them on the market. It will make your life a little bit easier, especially for geographic issues and other items that are going to come along with that whole process of being on a global computing platform. You have to use a time-weighted average of your calculations, especially for calculations of value. And then be aware of flash loans and that is an attack vector, and just program accordingly. Make sure when you're picking your vendor, you pick a good reputable vendor along the way. So that's kind of it for how we do oracles and how oracles can be manipulated to kind of just give bad information that can be reflected in your contract. And again, it's really all about information quality and information sampling that you're going to use along the way. And that's it for this lecture. I will see you in the next one.